Hello everyone. This lecture is on the topic cognitive radio technology, and basically we will be dealing with cognitive radio technology for the people who are beginning to do research in this area, because there is a lot of confusion in the area of cognitive radio technology, and people who want to do research in this area don't know the precise details of what to do and where to start. So I decided to make a video on this particular topic. We will not be dealing much with the theoretical details of cognitive radio technology. Rather, we will be dealing more with the mathematical details and the research problems, how to basically get the research problems, relevant research problems, and what are the key issues, the key mathematical details and key mathematical issues in cognitive radio technology on which we need to work. We need to find out new things. That is basically the objective of this lecture. So essentially we have cognitive radio technology. Cognitive radio technology. Now I assume that there are certain theoretical details which most of you must have read somewhere, that there is a licensed user, and this licensed user has the license authentication of the frequency bands, and this license is provided to this user by the particular state governments, the governments of that particular nation, and so on. And this particular licensed user, or the primary user, the licensed user, or we also call this as the primary user. So this primary user, or PU, it has a legitimate authority over the frequency band, and this authority has been provided to this primary user by the government. Now, in a particular region or at a particular time, it has been found that most of this spectrum that has been authenticated, that has been legitimized by the governments to this primary user, remains unused. So 90% of the time, this spectrum, almost for 90% of the time, it remains unused, and therefore the idea of cognitive radio technology was formulated by Joseph Mitola, that the unlicensed users, that is those users who are not having the license of this frequency spectrum, can use this frequency spectrum during that time when the primary users are not transmitting over these spectrum. So over this frequency spectrum. So basically, this is the idea of cognitive radio technology, and these unlicensed users are known as secondary users. You can find this explanation, or we will also know it as SUs. You will find this explanation in any paper, almost one. There are thousands of papers now. So you just write cognitive radio technology on the search window, and you will get almost like 80,000 to 1 lakh papers have already been published on this particular area. So you will read this explanation in several places. Now, so finally what we have is with us is that we have a primary user. Okay. And suppose we have a secondary user, and primary user is having a particular frequency band over which it is transmitting. So this primary user is there, and it is transmitting its signal over some frequency bands. And we know that many of the times this band is not utilized by the primary user. So during that time, the secondary user would be utilizing that frequency band. That is what we know. So for that purpose, this secondary user performs spectrum sensing. This secondary user performs spectrum sensing, that is, it senses the spectrum that belongs to the primary user. And what it is, why does it do spectrum sensing? Why does it perform spectrum sensing? To sense the presence of the primary user spectrum, the primary user signal over that spectrum, that whether these signals that are transmitted by the primary user are present over that spectrum or not. If they are not present, so the secondary user will start utilizing that spectrum during that time when the primary user signals are not present. And it has to continuously perform sensing, so that as soon as the primary user signal arrives on that spectrum, so immediately it has to vacate this spectrum, that frequency spectrum. Okay, so that is precisely the cognitive radio technology. A very broad explanation. The philosophy of cognitive radio technology is very deep and very vast also. For that, I will suggest you to read Joseph Mitola's paper and his PhD thesis that led to the formulation of cognitive radio technology and the development later on. So as of now, as I said earlier, that we will immediately go into the mathematical details. So the first thing that we saw here is that the secondary user is going to perform spectrum sensing. Okay, and it will sense the primary user spectrum, and when it is finding it vacant, it will use it. So suppose what happens now, basically this primary user signal, suppose the primary user signal is X. Suppose X is a signal that is transmitted by the primary user, and we have a particular secondary user here. So the signal that is received at the secondary user, signal received at the secondary user, it will be Y. Okay, and I write it as a function of time, so that is Y of t, and this will come out as X of t is the transmitted signal by the primary user, and we will have the additive white Gaussian noise that will be added here. And then we will have, since it is a wireless environment, so in the wireless environment we have a channel fading coefficient that represents the various obstructions that are there. Suppose there is a tree and there is a building, so this primary user is transmitting those signals. So all these signals that are traveling through this wireless environment, they get basically reflected and scattered from these obstructions, various obstructions, and then after getting reflected and scattered from these obstructions, they finally reach to the secondary user. So at the secondary user, basically the signal that is received is basically Y of t. We have this as the fading coefficient of wireless channel, and this is what any communication person must be knowing, that it is the AWGN, additive white Gaussian noise at the receiver of the secondary user. So now what happens is that how does this secondary user, when it receives the primary user signal, and that is Y of t, when it receives this Y of t, how does it decide on the basis of Y of t that whether the primary user signal is present or not? So there are various mechanisms to decide on the presence of the primary user signal. See, it is receiving Y of t. The secondary user is receiving the signal Y of t, and it has to decide after receiving, let us think from the point of view of a secondary user. This is a secondary user. It has a signal Y of t. It receives some signal Y of t. And on the basis of that Y of t, whatever it has received at it, it has to decide that whether X of t is present or not. That is what it has to decide. Okay. So either X of t will be present or it will be absent. If it is absent, then the secondary user will transmit. If X of t is present, the secondary user will not transmit. Okay. So we have basically, essentially we formulate two hypotheses. That is H1 and H0. Hypothesis H1 says that the primary user signal is present, and the hypothesis H0 says that the primary user signal, U signal, is absent. Okay, what is the primary user signal? That is X of t. Primary user signal X of t. Okay, so essentially, what will be the received signal now, Y of t, in both these hypotheses? Okay, so I'll write it here. Under the H0 hypothesis, the received signal, that is Y of t, that will be, we'll have simply the additive white Gaussian noise here under the H0 hypothesis. And H1, under H1 hypothesis, when we are saying that H1 hypothesis is true, our hypothesis H1 is true, then the received signal at the secondary user will have this entire thing that contains the primary user signal plus the additive white Gaussian noise. Okay, so this is essentially the thing. Now the secondary user has to decide H0 or H1. Okay, H0 or H1 decide between H0 and H1. Okay, which of them is true? Which of the hypothesis is true? Okay, because hypothesis is just a theoretical speculation, basically. So now, how does it decide between H0 and H1? Essentially, H0 is signifying that the primary user is absent. Okay, so there are various mechanisms that have been designed for this. One particular mechanism is called the energy detection. Okay, the second one has been called as a cyclostationary feature detection. Then we have the masked filter detection, and so on. There are various many mechanisms. As of now, there are almost like tens of mechanisms have been formulated for identifying. We have autocorrelation, coefficient based mechanism. And so on. The most widely used mechanisms in all of these, among all of these, is the energy detection mechanism, basically. And we'll first look into the energy detection based mechanism only. Energy detection mechanism, basically the philosophy behind energy detection mechanism is that if the primary user signal is present, then the incoming signal at the secondary user will be having a higher level of energy. Obviously, that is true. If the primary user is present, suppose I'll rewrite the hypothesis. Under the hypothesis, there is only additive white Gaussian noise, and under the hypothesis H1, we have basically HXT plus NT, where HXT is the primary user signal. This is the hypothesis H1. So it is very obvious that this signal Y of t will be carrying a higher amount of energy if the primary user signal is present. Okay, so essentially the secondary user will calculate the energy of this signal. Whatever signal it is receiving, it will calculate the energy. So practically, to calculate the energy, we know that the energy of the received signal, that is essentially from minus infinity to infinity, we have y of t square dt. But in practical implementation, we cannot do it in the continuous form because there will be many infinite values of y of t. We have to take certain number of samples to find out this energy. So we'll take a limited number of samples, certain number of samples, and we'll basically write it in the discrete form, the same equation. Basically, we will have y of n will be equal to n of n will look a bit